Concrete is naturally brittle. Typical stresses like impact, fatigue, and loading lead to cracking and eventual failure. Adding reinforcement to the concrete helps to absorb these stresses and to limit the formation of cracks, increasing the load-bearing capacity and ductility of the concrete structure. There are several ways of reinforcing concrete. We've all heard about rebar and steel mesh, but did you know steel fiber is just as strong and reliable? Since its introduction over 40 years ago, steel fiber reinforcement has proven its merits in the most demanding structures and applications. The core difference between steel fiber and other reinforcement solutions is that fibers are part of the concrete matrix, turning it into a composite material. Instead of providing strength in distinct locations, steel fibers form a reinforcing network throughout the entire concrete structure, increasing its overall ductility. So how does this translate into concrete behavior? Take a random concrete structure. When subjected to loading, compressive and tension stresses start to build. Over time, small cracks will appear in places where the stress reaches a critical point. Steel fiber interacts within the concrete matrix, absorbing tensile stresses at any point and in any direction. As a result, steel fiber picks up small cracks much faster than traditional reinforcement. When a crack occurs, the hooked ends of the fibers remain solidly anchored on each side of the crack, acting as a stress transfer media. Once the maximum bond strength with the concrete is reached, the pull-out takes full effect. This enables the next fiber to take over, delaying cracks from growing. Different loads require different steel fibers. To meet any design requirement, Beckart offers 3 steel fiber types: Dramix 3D, 4D, and 5D. Each fiber has a different hook, strength, and ductility. Consequently, they also behave slightly differently when dealing with stresses. Let's take a closer look. First up is Dramix 3D. When a small crack occurs, the 3D hooks firmly anchor inside the concrete matrix. As the stress increases, the hook slowly deforms. As soon as the fiber loses its bond with the concrete, the pull-out takes full effect. Dramix 4D provides the same process, but with even better anchorage and a significantly higher tensile strength of 1,650 Newton-square millimeters or more. Dramix 5D behaves differently altogether. Here, the hooks never pull out from the concrete. As the stress increases, the wire slowly elongates until it reaches its maximum strength. With a tensile strength of 2,300 Newton-square millimeters and elongation of 6%, concrete structures reinforced with 5D can take high flexural stresses over a long period. Based on these behaviors, we can conclude that Dramix steel fibers effectively increase the load-bearing capacity of concrete. It can be used in almost any concrete structure with or without additional reinforcement, where the ductility of your concrete structure depends on the length-diameter ratio of the fibers and the number of fibers used per cubic meter. It is essential that enough fibers overlap to create a continuous network in the concrete mix. Do you need help finding the right fiber and determining the right dosage? Beckart gladly provides expert guidance through each step of your project.